Hello, everybody. Okay, I have a math box and I will take one matchstick here. What I'm going to do? You guess? This catches fire. You know this, okay? Just a minute. I will keep this safely. Okay. Now, what makes this to catch a fire? Do you understand? What makes this to catch the fire? It requires a heat. It requires a heat to catch a fire. Where the heat comes from? It is from friction. What it is? It's from friction. The main topic is today is friction. Okay, friction. Hello. We'll take another example. Say for example, I'm riding a bicycle. Okay, I'm riding a bicycle in this direction. I'm already on the move, slow moving. Okay, my friends come here and he gives a little push. What he does? He gives a little push to me. What happens? My cycle moves further, little faster, right? What happens? My bicycle moves little faster. Instead of my friend giving the push from here, okay, he comes here and gives the push here. My bicycle stops. What happens? My bicycle stops because he is giving the force opposite to my moment of direction. Here he is giving the force along the direction of motion. Now, if the force is opposite to the moment of my moment, it going to be stopped. Okay, there is a force. In the same way, when the cricketer hits the ball, it moves along the surface of the ground. In the initial, it moves faster. At the boundary line, okay, this is a boundary line, it slows down. It slows down and stops here. Why it happens? Nobody is forcing like this, but there is some force to stop this. This force, this unknown force is called our main topic, the frictional force. It is called friction. Let us take our hands and rub it together. These two hands are in motion relative to each other. We will feel a heat. Why the heat? Because of friction. Because of friction. Okay? There is a motion and also the friction. We'll take another example. Say for this example, this is a plane and I have an object. Okay? I will just give a force. Force to move this. Force to move this. And it will stop here. Why? Why it stops here? Because of the friction. There is one force to stop this from this side. That is why it has been stopped. Okay? It has been stopped because the force is in this direction to stop this, because it was moving like this and the force acted upon like this. So it stopped. This force, unknown force, not visible force, is called friction. This is called friction. We'll explore a little bit further. Okay. Say this object, okay, what we have seen, this object, it is moving along this direction and it stops here, right? Stops here. There is a force like this. There is a force. This is called, we call it as a frictional force. Okay. The frictional force acts in this direction. What is the direction? Opposite to the motion. Opposite to the motion. Always the friction force is opposite to the motion. Once again, we'll come back here. If I push, the motion is in this direction and because it stops, the force, frictional force is in this direction to stop this. If I push like this, it stops here because in this scenario, the force, frictional force is in this direction. The moment is in this direction, frictional force is in this direction. Always, students, remember, the frictional force is always opposite. Well, little more further explanation is why the frictional force is there. Okay, there is a contact between this surface and this surface. Okay, we may see that these two surfaces, for example, this surface as well as this surface, are very smooth, right? But in reality, if we see it in the microscopic level, it is not a smooth. It is not a smooth surface. Always there are many irregularities. What do you call? Irregularities. It is like this. If I zoom it, okay, if I zoom this area, it shows like this. Okay, like this, because there are many peaks and valleys. Say for example, this is object. Okay, it has many peaks and valleys, irregularities. When I see in the microscope, and this object, like this is a surface, it interlocks. What happens? It interlocks. Okay, if I want to move this surface, this object along with this surface, what happens? This will create a hindrance. This makes very difficult to move this object because there is a valleys and peaks. There is a force opposite to the direction of movement. This is called friction. The friction is because of the irregularities of the surface. This hindrance, this makes the movement difficult. Here is an object placed on the surface, and this object has some weight. W is equal to mg. So this weight is acting downwards, and same opposite force, normal force, is acting opposite to the weight force. If I want to move this object, I am applying some force here. So there is a frictional force opposite to this force. Okay, we have already learned that the frictional force is always opposite to the direction of motion. So what will be the frictional force? The frictional force will be mu. We have learnt the mu, right? Mu n, that is normal force. Frictional force is equal to mu n. Okay. Frictional force is always equal to mu n. Mu is the coefficient of friction and n is the normal force exerted by the object. This n is always depending upon the weight of the object. If the weight of the object is more, then the frictional force is more, and you will need more force to push it or pull it to make it a move. Okay. If the weight is considered constant, then the other factor which is affecting the frictional force is a mu. Mu is always depending upon the material. Some materials has a less coefficient of friction and some material has a more coefficient of friction. If the coefficient of friction is more, then the frictional force is more. If the coefficient of friction is less, then the force required or the frictional force is less. Say for example, if the n is, okay, say for 5 Newton and mu is 0.3, what will be the outcome? It is 1.5 Newton, right? 1.5 Newton. If this mu is more, say for example 1, okay, into this is 5 Newton, then it is 5 newtons of force. If the mu is more, then the frictional force is always more. Friction is a bad or good? Can you decide it? Is it required or not required? Okay, my car has been stopped due to puncture or something else on the road. I require a more force to push it, or I may require to more people to push it. It's a bad. Friction is bad now. But when I run on the surface, okay, when I run on the surface, I need a friction. When I hold the pen, I need a friction. There is a friction force here to hold this. Otherwise, it would have fallen down. So, friction is very useful in sometimes and friction is very bad sometimes. Say for example, when we run the bearing, say for example in the bearing, the friction causes the wear out in the bearing and it costs some money. And in some cases, friction is very important because I save my life by applying the brakes on my car. That is a friction. Thank you for watching this video.